Yeah, we can also use the own color code. I also try to discuss later about that. Just a minute. So okay, so now you can see we can get the result about that. Okay, so this shapefile we can get from here. Suppose you are also importing the shapefile. Suppose you are importing the shapefile such as I already imported some shapefile. Suppose I want to import the shapefile about this Maputo. So simply import, click on here. Okay, then simply commenting this line and give this variable name, suppose ROI. Okay, and click to the run. So now I can get this result about this shapefile which I import in here. So again, I can get this result about this boundary shapefile which I imported in here. So using the same code, you can simply change your ROI. Sometimes you can also change your time period, and you can easily use this. In this time, this is our NDVI map, but this map has some problem. This problem is that you can check the value. Suppose, okay, so I want to use this. Suppose use here the ROI, and click to the run. Okay, so this is our NDVI map, but this NDVI map has some problem. This problem is that this map is not reprojected the scale value. Okay, if you want to check the scale value, suppose simply click on the inspector tab and click on this any portion of the map, then you can get the result. You can see 4268. Click on here, you can get this result. You can see 4207. Okay, so it's showing this type of result because this data set is not reprojected. Basically, you can see NDVI value range between this NDVI -1 to +1. We can get the -1 to +1, +1 to -1. So this is the range of NDVI. Okay, but in this time we can get the result look like this 4207, like this result we can got in here. Okay, so in this time it has some problem. This data set is not reprojected. So in this time we need to reproject this scale value. Otherwise we did not get the correct NDVI map. And we can easily reproject this data set. You can see here they already provide some scale. Okay, they already provide the scale. When you multiply all of those images with this scale value, then it reprojected. Okay, just multiply with this scale factor. You can see, so that's why they already provide the scale in here. So in this time we can simply multiply all of those images with this scale value. So here you can see how many images I want to got. Here I can get total 138 images. Okay, so this 138 images, every single image I need to multiply with this scale value. Okay, so every single image I need to multiply with this scale value. So at the same time I want to multiply all of those images. So now what kind of things I need to use in here? Anyone can guess it? So at the same time I multiply all of those images. So it reuse our code. So in this time we just help of function. Okay, so we create a function. This function help you to calculate all of those images with the scale value at the same time. So in this time we try to use the function concept in here. So at the same time we multiply all of those images. Total 138 images we multiply with this value 0.001. But when you want to randomly take the one image and multiply, then it's lot of time we need. Okay, it also possible. You can see that this is the first image, second image, third image, fourth image. So all of those images you can simply take the image ID and multiply. It's take a lot of time. But in this time when you want to use the function, at the same time all of those images we can multiply with the scale factor. Okay, so let's go about that. In this time we create a function. So for that I can simply write the code in here. So take a variable, you can use any variable name. I put the function variable name such as suppose scaled NDVI. You can use any name. I simply put this name, scaled NDVI. Okay, in this time I create a function. So this is my function variable name. Then I need to use here the function keyword. Okay, and then I need to input here the element name. So in this time you can see here I take only for the one element, image. Okay, if you want, you can also use the image. Suppose image 1. Suppose take the image 2 and up to image 138. Okay, so it's a long time when you want to take the single every image as the element. Suppose image 1, image 2, and up to image 138. So lot of element you need to take. Okay, so in this time we are not applying this approach, we are trying to apply the another method. In this time I take only for the one element. Okay, I take only for the one element. One element means that one image. Okay, I take only for the one image as a variable image, and then I simply put here the curly bracket. In this curly bracket I mention what is my argument. My argument is that this image which I take in here, this image multiply with my scale factor 0.001. Okay, this value and multiply. This is my argument. So for that I need to use a function, return function. Every function has a use the return, what outcome I can get from here. So I need to use a return function. I return this image which multiply with a scale factor. Okay, in this time you can say I take only for the one image, but rest of the image, what can I do? For the rest of the image, what can I do? You can see here 138 image. Suppose rest of the 137 image, rest of the 137 image I need to copy these properties. Okay, after multiply with the scale factor, it create a properties. These properties I copy. So for that I simply use a function, this function called copy properties. Okay, copy properties, this image. After multiplication I copy these properties and apply from mention here system time start and system time end. In this time, what is the system time start? System time start means that start date, and system time start means that end date. So between start and end, between this time period, I get total 138 images. This 138 images, I apply these properties after multiply. So in this time, all of those images is multiply with this factor, scale factor. So I again explain. So first of all, I take a variable name scale NDVI, then use that the function keyword and take only for the one image. Randomly I take only for the one image, and this image I multiply with this scale factor, and after multiplication it create a one types of properties, one types of new characteristics. These new characteristics I copy. So that's why I simply use the copy properties and apply from system time start and system time end. It means that from start time and end time, from start time end time, all of those images I apply. Okay, so this is the function. In this time you can see this function and this 138 image, there is the no connection. Okay, because this 138 image is stored in a variable, and this it's totally new code, this totally separate code. There is the no common connection. Okay, so this 138 image and this function, there is the no connection. In this time, this function I need to connect with this 138 image. For that I simply copy the variable and paste here, and for connecting I use a function, this function called the map function. Okay, after that use here the parenthesis and also close this parenthesis. So now this 138 image is connecting with my function. Okay, so in this time anyone any question about that, you can ask me, because this concept we are also use the a lot of time about the when I want to work with the Modis LST, all of time we need to use this concept. So in this time if you have any question or any doubt about that, you can ask me for get the clear idea. So any question in here or any doubt?
It's not clear for me.
Yeah, please.
Hello?
Yeah, I can hear you. Yeah, please.
Yeah, it's not clear. Yeah, it's not clear for me. If you can.
Okay, I again explain.
Yeah.
Okay, so first of all, you can see
Yeah.
this first of all, I check the inspector value. You can see I can get the value look like this. So 3000, 4000, this type of data I can get in here. But our NDVI value range will be -1 to +1. You can see +1 to -1 all time NDVI values. Between this range, we can get the NDVI. This is the NDVI index range. But in this time, which map I create in here, this map showing the result from 3800 for this type of result. Okay, so it means that this map, this NDVI map is not reprojected. This scale value. In this time, this scale value I want to reproject it. Okay, so that's why they're already provide. You can see they're already provide the scale about this NDVI. They're already provide this scale. In this time, when I multiply all of those images with this scale value, then it will be reprojected. So here you can see, here I can get total how many images? 138 images. This 138 images I need to multiply with this scale. Okay, so at the same time I need to multiply. That's why I use the function. So for that I simply take a function variable name and use the function keyword. I take a element name. So I take only for the single image or single element or single image. Suppose from 138 I take only for the one image. This image I multiply with this scale factor. But I have a rest of the other image. Suppose 137 image is also available. I also need to multiply all of those images. So after multiply, it creates a new characteristics or creates a new properties. These properties I need to apply. I need to copy. So that's why I simply use the copy properties and use here this element name image and put here the system time start and system time end. It means that from the system here I already put the time, start time and end time. Between this time period, all of those images apply these properties. It means that all of those images apply with this, multiply with this scale factor 0.001. Okay, so now this is the function I created, and this function I need to add with my 138 images. Okay, so for that I simply call this filter NDVI, because this filter NDVI stored 138 images, and for connecting this I simply use the map function. So basically this map is a function. This function connect which function I created. This function I created. This function connect with my overall collection or whole collection 138. So now if you want to check how many images I want to got, you can simply use the print and call the scale NDVI and use the size function. You can check, we can get the same number of images 138. We can get the same number of images 138. But in this time, this 138 image is reprojected this scale value. Okay, so in this time I use this 138 image and make the further analysis. So for that I simply copy this scale NDVI because it is stored total 138 images. Okay, simply copy and then simply paste in here. In this time I reduce this scale NDVI because scale NDVI stored the 138 image. This 138 image is reprojected. I use here the mean, all of the things will be same. Now click to the run. In this time you can see what happened. You can check about the result. In this case I can get the result look like this. Okay, so this result is not appropriate because I reprojected this result. So that's why in this time I need to change here. Mean pixel value to be start from the -1 and max pixel value start up to +1. Okay, click to the run. Because I reprojected the scale value so that I can get the result in this time between this range -1 to +1. Okay, so mean value is that I simply put here. Okay, in this time I can get the look like this. It also not appropriate this color. So I simply remove all of the color and I simply put my own color. Suppose I put here this color look like this. Suppose blue color. Then suppose put here the white color. Suppose put here the green color and click to the run. In this time from this combination I can get this NDVI map in here. Okay, I can get the result look like this. Okay, in this time if you want to check the value, suppose click on the export tab and click on this. In this time you can see I can get the result 0.4. Click on here I can get the 0.2. Okay, in this time this map is reprojected and we get the result within our range -1 to +1. This range we can get the result. Okay, so if you want to check the result for other countries, suppose I simply and remove that ROI which I imported, click to the run. In this time I can get the result for the Saudi Arabia. In this time all time we can get the reprojected our scale value and we can get the result our range -1 to +1. Okay, so very few vegetation in here you can see. Okay, suppose click on here. Now I can get this about this specific coordinate, what is the value 0.4. Okay, so you can see I think this is the cropland in here. Okay, so this is the NDVI map. Between this time period we can create it, and now we can get the reprojected our result -1 to +1. Okay, so in this time you can get the result from the modis. Okay, suppose any country boundary you can simply put here, or any shapefile you can put here, we can get the result in here. In this time I can put this time period look like this. Suppose you need the result for year of 2020, just simply put the time, change the time period. Suppose 2020 1st January from 2020 December, then click to the run. So now you can get the result between year of 2020. This NDVI map created. Suppose you want to check the result for another country, suppose put here, suppose Ghana, and click to the run. Okay, so now you can get the result look like this. Click to the water body. We can get the negative value for the water body, and dense vegetation we can get the higher positive value. Okay, in the NDVI. Okay, so now this is our NDVI map. We can create it in here. Okay, so now we can easily export this map from here and work with the ArcMap software for representation of our research paper work. I also try to do later. Before that, I also try to discuss about the Landsat image, because exporting, this exporting part is the same. When you want to export the Landsat image, Sentinel image, or when you want to export this type of map, same code we need to use. Okay, so that's why at the same time I also try to show you the two things, then it also better. So this is our map. We can create it for the NDVI map from the modis. Using the same process you can easily apply the other rest of the dataset. You can see for creating this map. Here the lot of modis dataset is available in here. You can see evapotranspiration, then albedo, then also you can see the burned area monthly. So lot of dataset is available in here. So you also try to do for your own self for creating this type of map in here. And after that I also try to show you that how you can easily export this type of map and also make the NDVI map. Okay, so in this time, anyone any question you can ask me any for this code. Anyone any question for creating this map?
Sir,
yeah, please.
I have a question, sir.
Yeah, please.
Which NDVI is better, the NDVI created from Modis or the NDVI created from Landsat and Sentinel?
Yeah, so basically it's totally depend on the resolution. Landsat we can get the better resolution, so Landsat is the better than Modis. Okay, so Landsat is better, and then also better for the Sentinel is also better, because it's totally depend on your resolution. So when you want to work with the high resolution imagery, then we can also get the better result or better accuracy. So that's why all time use the high resolution imagery. Okay, I also try to show the Landsat image how can you do that, then it also better. I also try to show them Landsat, Modis, Sentinel, all of those satellite images, how you can easily work for the different remote sensing work. I also try to show you all of the things step by step. So this is the Modis part. I also try to show in here in this time. So you can see other data set is also available for the Modis for the track gross primary productivity. So this type of data set you can also try to filter, display. Okay, then it also practice for you. And face any problem for any data set, you can also contact with me in our WhatsApp group, then I hope you can easily get the solution about that. Okay, so in this time I can also only use the dataset data visual indices. This dataset I want to use, but it has also other dataset you can also try to use. Okay, so in this time, for the before is showing the exporting part, I also discuss about the Landsat image, how you can easily filter. After that, I also try to show you that how you can easily export this type of map, and also work with the ArcMap software for creating this map. Okay, so let's go a slide. And we can also create the time series chart about that. We also try to discuss about that. How can easily make the time series chart for the different time period? What is the condition of the NDVI? Okay, this type of analysis we'll also try to discuss. So let's. So in this time, we talk about that how you can easily work with Landsat image. Suppose how you can easily filter this Landsat image, and also how you can easily filtering and visualizing the satellite image such as Landsat image in Google Earth Engine platform. Okay, so when you want to filter the Landsat or Sentinel all time, it depends some factor for the filtering process. Filtering, it's depend some factor, such as first factor is that region. Suppose you want to need the satellite image for the Dhaka city, so Dhaka city is a filtering factor. Such as you want to need the image which image will be not more than 1% cloud cover. You want to filter the image specific metadata. So this is the one kind of filtering factor. Suppose you want to need this image for the year of 2017. You want to need the image for the dry season. You want to need the image for the wet season. So it's filtering factor. So when you want to filter any types of satellite image, it can be Landsat, Sentinel. We always follow the three factor. Okay, first factor, it represented the where. Suppose I need the satellite image for the Dhaka city, so this is the where. And also you can see this is the another factor, how. I need this image only for the less than 1% cloud cover. And then another factor is the when you want to need the image. It can be dry season, it can be rainy season, it can be any specific time period or any specific date. Okay, so when you want to filter the any types of satellite images, we just follow this three factor and filtering our satellite images. So let's go. We try to show you the practical example. So just I simply click on the Landsat because I'm to work with the Landsat, and also open a new code editor. Okay, so just I simply, okay, so here you can see the Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, all of this image collection. When you want to filtering, same process. I want to show the Landsat 8, so you also try to practice for the Landsat 9, Landsat 7, you also try to practice. So I will show you the Landsat 8, and filtering process is the same for the Landsat 9, Landsat 7, Landsat 5. That is some difference about their band and band. Okay, other thing also you can see some surface reflectance, top of atmospheric, raw image. So all of those images, when you want to filtering or exporting, the same process we need to apply. So in this time, I want to work with suppose top of atmospheric, but you can also apply the same process for the surface reflectance, raw image. Same process we can easily apply. Okay, so I simply click on the top of atmospheric for the Landsat 8. So now I can get all of the information about the Landsat 8 image collection. Landsat 8 availability time period we can get in here. Okay, also you can get the dataset provider. This is the unique ID of the Landsat 8 top out atmospheric dataset. Okay, so first of all I need to import this dataset. Just I simply copy from here and paste in my code editor. and give a variable name. Suppose I put this variable name is that L8. You can use any name. I simply put this name L8. Okay. So now you can see here. Now the full image collection is stored in this variable L8. Okay. So now I want to check how many images are available for the whole world between the time period year of 2013 to 2023. Between this time period, how many images are available for the whole world for the Landsat 8 top of atmospheric. So we can check it. So just simply use the same function, print function, and call the L8, and after that use a size function. Okay, so click to the run. So now you can see determine how many images we can get. We can get the large number of collection for the Landsat 8 image collection. So it computing this value, how many images are available. Okay, so here you can see we can get the more than 1 million images are available in here. So totally large number of collection we can got in here. In this time, this result we can got for the whole world. Okay, so in this time I don't need for the whole world, I need for the specific region. I need the satellite image for the specific region. Okay, so for that, first of all I simply import my shapefile. Which region I want to need this satellite image. So just I simply import the shapefile of suppose Dhaka city. Suppose this is my region of interest. I simply put this name, suppose ROI. You can use any name. Suppose I also display the result about this boundary shapefile. Put here the map.add layer. Map.add layer. And call the ROI. And also focus the center. Map.center. Object. And use here the ROI. Zoom level suppose 10 and click to the run. Suppose this is my area. Okay, for this region I want to need this satellite images for the specific time period. So here I can get the large number, but this large number I can got for the whole world, but I don't need for the whole world. I need only for this region. Only for this region how many images are available I want to check. Okay, so let's go. So for that I simply take a variable. Suppose this variable name is the filter region. You can use any variable name. I use the filter region. After that, this large number of image collection is stored in a variable. This variable name is the L8. Okay, simply call the L8 and paste here and use a function filter bounds function. Okay, so filter bounds is a function. Basically this function intersecting with your region of interest. The full image collection intersecting with your region of interest. So in this time we can check about that argument geometry. So geometry means that your boundary shapefile variable name. Boundary shapefile variable name is ROI. So simply call the ROI. Okay. Now let's check how many images are available for this region. I want to check it. So use here the print function. Print and call the filter region. Simply copy and paste and use here the size function. So now we can check about the result how many images are available for this region of Dhaka city. Here we can got total 408 images. Okay, these 408 images are available for the Dhaka city. Okay, and this time period is that, what is the time period? This time period is the year of 2013 to 2023, the full time period. I can get this 408 images. Okay, in this time from 408 images I want to need only for those images which image will be not more than 1% cloud cover. Okay, from 408 images, I want to need only for those images which image will be not more than 1% cloud cover. Okay, so for that I simply use a function. So take a variable, suppose filter metadata. You can use any variable. I use the filter metadata. So now you can see here, I simply call the 408. So simply copy this variable name because 408 is stored in this variable. Simply paste here. From 408 images, I want to need only for those images which image will be not more than 1% cloud cover. So simply put here this function filter metadata. Okay, and check about that. You can see it has the property name, operator, and value. So first of all, name. What is the name? Name is the properties name. You can see here the image properties, cloud cover land. Okay, I want to work with for the cloud cover less than 1%. I simply copy this cloud cover and paste here, and it is a string. You must be using the quotation and paste this operator name. So properties name, then operator is that I simply put here the suppose less than and put the value for suppose less than 1%. Now I want to check how many images are available for my region of interest which are less than 1% cloud cover. I want to check it how many images are available. Simply copy and paste here and use the function size function and click to the run. So now you can see here I can get total 63 images. Okay, this 63 images is the less than 1% cloud cover for the Dhaka city region. Okay, so now from the 63 images, I want to need only for those images which images are available for year of 2000, suppose 2021 or 22. Okay, basically this 63 images, this time duration is the full time duration. Okay, and from this time duration I want to select the specific time date. So for that, take a variable. Suppose this variable name is the filter date, and you can see 63. This 63 image is stored in a variable. What's the variable name? Filter metadata. Simply copy and paste. Okay, and use a filter date function and put here the start date and end date. Suppose I need this image for year of 2020, 1st January from, or any time period you can put, or rainy season, or wet season. Put here the 2020, suppose December 31. Okay, so now you can see what happened. From 63 images, I want to choose only for those images which images are available between this time period. Now let's check how many images are available between this time period. Just simply use the print function and call the filter date and paste and use the size function and click to the run. Okay, we can get only for the 7 images. Okay, so now we can check the result. First of all, I can get the large number of image collection for the whole world. Then I filter according to my region. Here I can get 408 images. From 408 images, I choose only for those images which image will be not more than 1% cloud cover. Here I can got 63 images. From 63 images, I choose only for those images which images are available for year of 2020. Here I can finally I got 7 images. Okay, so this is the filtering process. When you want to filter any types of satellite image, it can be Landsat, Sentinel. We just follow the same process. Okay, so first of all, filter bounds. It represented your where. Okay, your area. Which area you want to need the satellite image. Then filter metadata. It represented how. Okay. So in this time, I want to need only for the images which image is less than 1% cloud cover. Sometime you need the suppose 2% cloud cover, 3%, 4%, 5%, 10%. Okay. So basically this value will be increasing. When you want to work with the coastal area or river bank, you need the satellite images, then you did not find out the less than 1% cloud cover is not available. You can put here the less than 1% and check how many images are available for this region. You find out the 0. It means that less than 1% cloud cover image is not available for this region. Then you have to increasing the value, okay, and check at least how less than how number of cloud cover image is available for this region. Okay, suppose you can work with some coastal area or river bank, and you can put here the 1, and you can get the totally 0 number of image. It means that there is the no image for available less than 1% cloud cover. Okay, then you have to increasing the value and check how number of images is available for this. What is the less than how many cloud cover, how many percentage of cloud cover is available for this region, you want to check. Okay, and then it's when. Okay, when. Okay, so when you want to filtering this satellite images, so where, how, when. So for the where, we are using here the filter bounds, basically this function intersecting. So this is the full image collection intersecting with our region of interest. Okay, and from this I can got total this 408 images for my region. From that I filter less than 1% cloud cover, how many images are available. This is the filter metadata. So basically this function filtering the image properties. So I want to use here the image properties cloud cover and choose the less than 1% cloud cover and find out the 63 images. From the 63 images I want to find out for the specific time period. Here I can got total 7 images. Okay, so this is the filtering process. In this time, anyone any question about that, you can ask me for the filtering process. Anyone any question? Yeah, size is the same for all of the. Okay, so size is a function, so it's mainly determine how number of images are available.
Sir, can we write this in one variable? It's
yeah, so it's also possible. Yeah, so I also go to in here. So in this time I try to show you that how we can easily filtering, but and every function you can see, for every function I take the different variable first time for your understanding. But when you write the code, we did not write the function variable name. Okay, different variable name we don't need to write. We can just only for the one variable and use the dot notation and put all of the function one by one. So it will be shortage our code and make it easier. Okay, so for that I also go to here after some time. So in this time you can check, I can get total 7 images. Now I want to check what is the acquisition time period. Because this year of 2020, this total 7 images is not captured at the same time. It captured the different time of the year. Okay, so I want to check the time. So for that, simply use the print function and call the filter date. Simply copy and then click to the run. So in this time I can get this acquisition time period, all of those total 7 images. Yeah, so you can get all of those practice code, there is no problem. And I also share all of the asset. So basically this type of shapefile, this type of code we can easily access and also practice, there is no problem. Yeah, so in this time here you can see, here I click on here, so here I can get total feature. So here I can get total 7 images. You can see total 7 images. The first image is that year of 2020. It is the 11th February, 26th January, 11th February, 30 March, 27 December, 9th November, 9th November. So here I can get all of those images acquisition time period, as well as we can also get the band, how number of band I can got in here. Okay, so in this time, suppose I want to work with the single time period image. Okay, you want to work with the single time period image. So for that, simply click on here. Suppose I want to work with this image, simply click on here and copy this ID. Simply copy this ID. Okay, and after that, take a variable. Suppose this variable name is that I put the variable suppose image and use that ee dot image and put this id. Okay, and this id also clip with my shapefile. Shapefile is that ROI. Okay, now display the result. Simply use at the map dot add layer and use at the image and click to the run. So now it display the specific time period, specific date satellite images. This date is the year of 2020 11th February. You can get the image look like this, you can see, and this image is not cover my full region. You can see this image tiles is not cover my full region. It has also some part is not covered, you can see. Okay, so in this time we are applying the another method. So we are applying, suppose second image, we try to check about this condition about these tiles. Simply click on here and then simply
Kuldip, can you please mute your mic?
Yeah, can you hear me now? Hello. Okay, so kindly muted this outside sound.
Yes, sir.
Then it also better. Yeah. Yeah, same. Yeah, size function is the same for the Sentinel, Modis, as well as all of the dataset. Size is a common function. When you want to identify how many images is available, then we are using at the size function all time. Okay. Okay, so now I check the second image. What is the condition about these tiles? Simply copy and then paste here and click to the run. Okay, so this tiles is the perfectly cover my region, you can see. Okay, so you can see this is the satellite image I can get in here, but this satellite image is look like this as a default color. So here you can see I did not use any visualization, so that's why it look like this. So in this time I just work with that. Simply click on here and you can see the band combination I can use here. So I use at the red, then green and blue or RGB color or true color composite. Also stretch the 98% for better looking and apply. So now it display the map. You can satellite image, you can see. So this satellite image, we can get the satellite image, and this time is that year of 2020 26 January. We can get the satellite images, and from that we can easily use the different types of band combination from here, and we can easily get this result and also display the result in here. Use the different types of band combination, true colors, false color, other types of any types of band combination. You can easily simply select in here and you can easily get this result. Such as put here the before, then B3 and B2, true color composite, and paste here. Then I can get the result natural color look like this about this data, satellite image. Okay, in this time you can see this visualization is only showing in here, but this visualization also need to import. Simply click to the import. When I click the import, you can see new line of code will be added in here. Simply copy this variable name and paste after the object name. Now click to the run. So now you can see this visualization we set with my code. Okay, so I can set in here. So this is the one process. Sometime some analysis or some research work you have to work with for the single date image. Okay, suppose you want to need single time period image and work with that. So then you can easily get this image ID, single time period image ID, and work with this. So now we can easily use this image for making the LULC map, NDVI map, NDVI map, or other types of remote sensing work. We can easily do single date images. Okay, and we can also take the another type of composite. Suppose you want to create the median composite in Google Earth Engine platform or mean composite. This type of composite we can also create it in here easily. So I think some question, check. The percentage of the stress is the reflectance value. Okay, So reflectance, what's the range you want to show? Okay, so 90% or 98%, then it is also better for the reflectance value for the showing this good result or quality view. And what is the use of EVI? EVI is the enhanced vegetation index, and NDVI and EVI, it has some common difference. So it is the quantify and quantify of vegetation. Okay, quantify. Okay, you can simply search here Google. I'll also try to show from here. Suppose NDVI and EVI. Yes, from this link we can also get the better idea about this United States this geological survey website. You can also get this information about this two types of indices. So basically, normalized difference vegetation index can be used to quantify vegetation greenness. Okay, and EVI, it is that corrects for some atmospheric condition, and also canopy background noise is more sensitive areas with the dense vegetation. Okay, so when you want to quantify vegetation, then we are also using here the NDVI, and EVI, it also some added some of suppose atmospheric condition and canopy background noise is more sensitive in the when you want to identify the dense vegetation. Okay, and also read this article, then you can also get this better idea about this two types of NDVI and EVI. Okay, but we can use here the same process, and you can see EVI is also some equation. Okay, this type of equation I also try to show you that how you can easily calculate it and also monitor the EVI and NDVI. Then it also better idea you can easily get from here. Yeah. Okay, so now you can see here. Okay, so I check the another question. Okay, import the satellite image like drone data, high resolution planet data, or yeah, it also possible. Yeah, so suppose you want to work for the high resolution imagery, you can easily import it all of those high resolution imagery in Google Earth Engine platform and work with the same process. Okay, in this time which process I want to show you, that you can also import these satellite images or drone images, then also try to work with that, such as you can also work for the sport satellite images in here. Also the different types of high resolution image that you can easily buy and work with in the Google Earth Engine platform. Simply you can see there is another option in here. So okay, you can see tip option. You need to also put here this format you need to import it and work with that. Okay, then we can easily display this satellite image, high resolution satellite imagery, and also work with that. Okay, okay, it also possible when you want to work with the high resolution imagery, it also possible. Yeah. Okay, so now you can see here we can display these satellite images for the single time period. If you want, you can also create the median composite. So how you can easily create the median composite? So for that, I also commenting this line because I also send you the practice code. So for the median composite, you can simply take a variable. Suppose put the variable name is the final. Suppose final image, and call the filter date, because in this time I create the median composite from total 7 images. Okay, and this total 7 images is stored in this variable. Simply copy and paste and use here the median function, and median is an empty function, so that's why there is no argument. So I simply use here the map dot add layer and then call the final image, and also need to clip with the shapefile is that ROI. Click to the run. So now I can create the median composite, and this median composite created from the total 7 images. Median value from the total 7 images, median value, we can create the composite look like this. So I want to add the visualization. So simply add the suppose red, green, and blue band. Also increase 98%, reflectance range, and then apply. So now I can get the image look like this, and also import that. And after that, simply copy this visualization parameter. Simply copy and paste after the object name. This is the object, and put here this variable name. If you want, you can also use here the layer name. Suppose I put this layer name, suppose true color. You can use any name, there is no problem. So now this layer is also display the true color about this image. Okay, so now you can say create this image look like this, and you can see here when I want to work with suppose every function, filter bounce function, I take a new variable, filter metadata function, I take a new variable, filter date function, I take a new variable, But if you want, you can take only for the one variable, and under this variable you can put all of the function. So for that, I simply just commenting all of the line of the code, simply select and press Control and forward slash together. So now it's commenting. In this time I take only for the one variable. So for that, suppose I take the variable is that image, okay, and first of all I call the L8 because it is stored my full image collection, and put here the filter bounds function, it intersecting with my region of interest RY, and then use here the dot notation. Space is doesn't matter, okay, if you want you can use here, there is no problem, or if you want you can also use here, there is no problem. So space is doesn't matter, okay. I put here this dot notation and put here the suppose filter metadata, and put here the cloud cover less than 1%, and then put here the dot and put here the filter date, and put here the suppose year of 2020 1st January from 20 December 31, okay. Then take suppose median composite, and then simply clip with my shapefile with RY. Now I display the result. That simply use here the map dot add layer and call the image, and after this simply copy the visitor variable name from here and paste here and click to the run. I can get the same result, okay. So in this time you can see very short time I write the code, and I did not use the variable name again and again, okay. So I take only for the one variable, and in this variable I put all of the function, okay. I can get the same result, okay. So now we can easily apply the same code for other region. Just simply change the ROI. Suppose I need the result for the other region. Suppose I want to need the result for okay, so I simply select this region. Suppose this region I simply put here. Just I simply change it, simply remove that ROI, and this table I simply change it as a ROI. Now click to the run. I can get the satellite image for this Sagline sub-district of Bangladesh. Okay, so I can say I can get this satellite image for this region, okay. So just using the same code you can simply change the ROI and you can easily get the result, you can see, okay. So this is the another region satellite image, okay. So any region which you want to need, simply put this and you can easily get this result. Suppose I need this result for this, simply click on here and remove the previous ROI and put here this ROI again, ROI, and click the run. So now I can get the result about this region. Okay, so in this time you can see we did not get the satellite images because this for this region there is the no image, which is the less than 1% cloud cover image is not available, okay. So that's why you can see there is the no image is loaded, okay, because this region is the cloudy region. So that's why there is the no image which are the available less than 1% cloud cover, okay. So in this time I can simply increasing the value. Sometimes you can also face this type of problem, okay. Just simply increasing the value, suppose 5%. I can check what is the content of the 5%. Yeah, 5% is available. Yeah, but very cloudy image we can got in here, you can see, okay? So when you face this type of problem, just increasing the value, and Google Earth Engine platform has the another tool or another function how using this you can easily remove the all of the cloud, okay. So this type of lecture I also provide you the next part of the class how can you do that. Suppose I need this result for this region, simply import that and simply remove this previous ROI and put here this ROI, and for this reason you can easily get the 1% cloud cover. So no problem. So now click to the run. Okay, so now you can easily get the satellite images for this region. Okay, for the year of 2020. Okay, now you can easily use this image for making the different types of remote sensing analysis. Okay, so this is the process for filtering and visualizing the satellite images. So in this time, any question you can ask me about that. Anyone any question or any doubt in here? Any question? And now after that we try to discuss about the
Sir,
export.
the filter process is different for Sentinel.
No, same process we need to apply when you want to work with a Sentinel. Okay, just Sentinel has some difference about the image properties. So here you can see cloud cover. This image properties only for the Landsat image, but Sentinel it will be cloud pixel percentage, cloud pixel assessment. So you can check it from the image properties from here. Okay, so image properties you also try to check about the image properties. Okay, so I also try to show you the further class how you can easily do that about the Sentinel. Okay, but if you want you can also try to now the same process you need to apply when you want to work with that for the Sentinel. Okay, suppose filter bounds, plan radar, filter date, median, same function. It has some difference only their image properties. Landsat and Sentinel only difference for the image properties and also difference for their resolution. Otherwise all of the things will be same. Okay, so any question in here? Okay, so now we are moving to this part how you can easily export, and here you can see already create this type of map in here for the what is the Ghana. Okay, so let's go about that how you can easily do about that. We try to discuss.